This is why the next major war will be won or lost in orbit before a single bullet leaves a chamber on Earth. The United States military cannot move troops, guide a missile, talk to a submarine, or spot an incoming nuclear warhead without satellites. For the first time since the Cold War, those satellites are being actively threatened by nations that built weapons for exactly that purpose. America's sixth and smallest military branch, the U.S. Space Force, manages roughly 515 satellites on a budget approaching $40 billion. China has restructured its entire military space apparatus into a dedicated aerospace force, and Russia has tested orbital weapons that the Pentagon described as unusual and disturbing. What military planners call orbital dominance is no longer a planning exercise or a war college seminar topic. It is an active competition happening right now above our heads, and whoever holds the high ground above Earth's atmosphere will dictate the terms of every fight beneath it. Getting here took decades, and it started not with rockets and astronauts, but with spy cameras and film canisters dropped from orbit. On August 18, 1960, a mission called Discoverer 14, part of the classified Corona program, returned the first successful photo reconnaissance imagery from space. One pass covered 1.65 million square miles of Soviet territory, which was more than every prior U-2 spy plane flight combined. That single achievement locked in a pattern that has only deepened across 6 decades, where the military that sees from orbit controls what happens on the ground. Through the 1960s and 70s, the U.S. built an orbital infrastructure that became the central nervous system of its war machine. Transit navigation satellites, guided submarines, Defense Support Program infrared sensors detected missile launches from geostationary orbit, and the first GPS satellite reached space in 1978. Air Force Space Command stood up in 1982, with the original U.S. Space Command following in 1985. And then came September 11th, which reshaped everything. Space Command got absorbed into Strategic Command, and for 16 years, space officers found themselves competing against fighter pilots and bomber crews for funding and attention inside the Air Force. 2 separate commissions sounded the alarm. The Rumsfeld Commission in 2001 and the Allard Commission in 2008 both warned of a coming space Pearl Harbor and recommended creating a separate space service. Neither warning produced action, and that changed only when a rival power forced the issue. On January 11, 2007, China destroyed one of its own weather satellites with a ground-launched missile at an altitude of 865 kilometers. That single test created over 3,000 trackable fragments and an estimated 35,000 pieces larger than 1 centimeter, most of which will circle Earth for centuries. It remains the worst debris event in spaceflight history, and it sent a clear message that China could hold American satellites at risk. 12 years passed before the United States responded with an institutional answer. On December 20, 2019, the Space Force was officially established, and today it fields approximately 9,670 uniformed members called Guardians, which amounts to less than 1% of total Defense Department personnel. Fewer people than a single Army division now carry responsibility for the orbital systems that every other military capability depends on. What exactly do those systems do, and why would losing them be catastrophic? 5 mission areas define American space dependence, and each one represents a single point of failure. GPS comes first, covering positioning, navigation, and timing. 31 operational satellites in medium Earth orbit underpin virtually every weapon system the U.S. fields. When coalition forces fought in Operation Iraqi Freedom, nearly 70% of munitions were precision-guided, and most of those relied on GPS to find their targets. The economic exposure runs even deeper. GPS has contributed an estimated $1.4 trillion in cumulative value to the U.S. economy, and a sustained outage would cost roughly $1 billion every single day. Missile warning comes second. 6 geostationary satellites in the space-based infrared system, known as SBIRS, scan the planet for missile launches. The price tag on that system reached a staggering $19.2 billion, nearly 4 times the original estimate, and Space Command used it to detect and track over 6,000 missile launches worldwide in 2025 alone. Satellite communications come third, and here is where the commercial dependency gets real. During Operation Iraqi Freedom, approximately 80% of U.S. military satellite communication capacity came from commercial providers. That dependency has only grown since then. The Pentagon confirmed in December 2025 a dedicated 480 satellite military constellation called MILNET through SpaceX's Starshield program, with a contract ceiling expanded to $13 billion. Intelligence and reconnaissance make up the fourth pillar. SpaceX holds a $1.8 billion classified contract with the National Reconnaissance Office for hundreds of small spy satellites, and over 183 Starshield spacecraft had reached orbit by April 2025. Space domain. Awareness rounds out the list, with the Space Fence radar on Kwajalein Atoll now tracking over 47,000 objects in orbit, building a catalog of everything up there so the military knows what belongs and what does not. Strip away any one of those 5 pillars, and the joint force degrades badly. Strip away 2 or 3 at the same time, and you are looking at a military that cannot navigate, cannot communicate securely, and has no warning of incoming missiles. America's adversaries understand this perfectly, which is exactly why they have spent decades studying how to exploit it. China's military space program went through its most dramatic restructuring on April 19, 2024, when the People's Liberation Army dissolved the Strategic Support Force and replaced it with 3 independent services, including a dedicated Aerospace Force. That mirrors what the United States did with the Space Force, and it tells you Beijing now treats space as a warfighting domain rather than a support function. An estimated 157 military satellites fly under Chinese control, including the Beidou navigation system with more than 35 spacecraft. During 2024, 5 Chinese experimental satellites conducted what the United States Space Force described as dogfighting in space, maneuvering within less than 1 kilometer of each other in orbit. In January 2022, China's SJ-21 satellite demonstrated something that should worry every defense planner on Earth, grabbing a defunct satellite and physically towing it 3,000 kilometers above geostationary orbit. That capability works just as well as a weapon as it does for debris removal. Russia's approach looks different, but it carries equal danger. On November 15, 2021, a Russian direct ascent missile destroyed the Cosmos 1408 satellite, scattering over 1,500 trackable debris fragments and forcing International Space Station astronauts to shelter in their emergency capsules. But the kinetic kill turns out to be the least sophisticated tool in Russia's counter-space arsenal. Their co-orbital inspector program, codenamed Nivelier, operates like actual Russian nesting dolls. In early 2020, satellites designated Cosmos 2542 and Cosmos 2543 shadowed a United States KH-11 spy satellite. Then, on July 15, 2020, Cosmos 2543 ejected a high-speed projectile into space. The Pentagon called it an anti-satellite weapons test. Russia also fields the Peresvet ground-based laser, operational since December 2018, which can blind satellite sensors at altitudes up to 1,500 kilometers. The most alarming development surfaced in February 2024, when intelligence revealed that Russia is building a nuclear anti-satellite weapon. A nuclear detonation in low Earth orbit would not just destroy one target. It would be indiscriminate, potentially rendering an entire orbital band unusable for a year and threatening every nation's satellites, including those belonging to Russia's own allies. When the United States and Japan brought a resolution to the United Nations Security Council reaffirming the ban on nuclear weapons in space, Russia vetoed it. None of this stayed theoretical for long, because we've already watched space-dependent warfare play out in a real conflict. On February 24, 2022, roughly 1 hour before Russian ground forces crossed into Ukraine, military hackers launched malware called Acid Rain against Viasat's satellite broadband network. Tens of thousands of modems across Ukraine and Europe were destroyed, and 5,800 wind turbines in Germany went offline as collateral damage. The whole attack was designed to blind Ukrainian command and control at the exact moment of invasion. Within 48 hours, Elon Musk activated Starlink service in Ukraine. By December 2023, 47,000 terminals had been delivered to Ukrainian forces. Starlink enabled drone operations, artillery fire correction, and encrypted battlefield communications that Russia could not shut down. When Russian electronic warfare units tried to jam the signal, SpaceX pushed software updates to counter the interference at a speed the Pentagon's Director of Electronic Warfare, Dave Tremper, called eye-watering. One Ukrainian soldier told Foreign Policy that Starlink changed the war in Ukraine's favor because Russia had tried to destroy their communications, and now they could not. Commercial satellite imagery from Maxar and Planet Labs made Russian troop buildups visible to the entire world before the invasion even began, undermining Moscow's information control in a way no previous conflict had experienced. Ukraine settled a question that defense planners had debated for years. Commercial space assets are now as operationally critical as classified military systems. That creates new strengths in the form of rapid software updates and commercial innovation. But it also creates a deep vulnerability because Russia has explicitly signaled it views commercial satellites supporting Ukraine as legitimate military targets. The Space Force's answer carries a name that sounds bureaucratic but describes a different way of thinking about space architecture. Proliferated architecture means replacing a handful of irreplaceable billion-dollar satellites with hundreds of smaller, cheaper ones that can absorb losses and keep functioning. The Space Development Agency is building exactly this through its proliferated warfighter space architecture. Tranche 0, consisting of 28 satellites, already orbits overhead. Tranche 1, with over 161 satellites, began launching in September 2025. In December 2025, the Space Development Agency awarded $3.5 billion for 72 tracking satellites in Tranche 3. The logic behind it is straightforward. You cannot kill what you cannot catch. And catching hundreds of targets spread across low Earth orbit is a much harder problem than taking out a few large ones. But the race between resilient architecture and adversary capability is uncomfortably tight. General Hyten warned before his retirement that the U.S. had put the president in a tough spot because it had a handful of fat, juicy targets while the adversary had built hundreds of targets that are difficult to get after. The shift from vulnerable to survivable has to happen faster than the threats mature. And right now, that margin looks thin. One more dimension makes this contest uniquely dangerous, and it has nothing to do with weapons. Every destructive anti-satellite test fills orbit with debris that threatens everyone. China conducted a 2007 test that alone scattered fragments that will circle Earth for centuries. SpaceX's Starlink constellation performed 144,000 collision avoidance maneuvers in just the first half of 2025, which works out to roughly 1 every 2 minutes. A 2025 analysis found that debris concentrations between 520 and 1,000 kilometers altitude have reached levels that could sustain runaway, cascading collisions. The scenario physicist Donald Kessler warned about back in 1978, where debris creates more debris in an unstoppable chain reaction. The European Space Agency's numbers paint a stark picture, with 54,000 objects larger than 10 centimeters in orbit, 1.2 million objects between 1 and 10 centimeters, and 140 million smaller fragments. The 1967 Outer Space Treaty bans nuclear weapons in orbit, but says nothing about conventional weapons, ground-based anti-satellite systems, or directed energy lasers. The arms control framework that is supposed to govern space simply does not cover how space is actually being weaponized. So here's where everything stands as of 2026. The Space Force budget has grown from $15.4 billion in fiscal year 2021 to approximately $40 billion in fiscal year 2026, a pace of growth that reflects genuine urgency. The proliferated constellation is transitioning from demonstration to operational capability, and commercial integration with SpaceX, Rocket Lab, and others is accelerating faster than anyone predicted 5 years ago. At the same time, China is reorganizing and building at speed. Russia is deploying weapons that could turn entire orbital bands into dead zones, and the debris environment deteriorates year by year with no enforceable international agreement to stop it. The premise of this video was direct. Whoever controls space will control the outcome of the next major war. What the evidence makes clear is that this is not a scenario being gamed out in a future planning exercise. It is the current state of affairs. Every GPS signal guiding a munition, every missile warning protecting a city, every encrypted link between a command post and a forward unit travels through orbit first. A service of fewer than 10,000 people carries the weight of ensuring all of that survives contact with adversaries who have spent decades figuring out how to tear it apart. The high ground has always mattered in warfare. What has changed is that the high ground now sits 35,000 kilometers above your head, moves at 17,500 miles per hour, and belongs to whoever fields the most capable and survivable systems first.